What about the fake diamonds at jewelry stores? What are those?
Diamonds themselves cannot be made in a laboratory very well. But crystals with similar properties and appearances can be made. One popular type of simulated diamond is a cubic zirconia crystal, which is a crystal with the chemical formula ZrO2. Cubic zirconia are more dense than diamonds. Or, in other words, a cubic zirconia is heavier than a diamond of the same size. They are also a fairly hard material as minerals go. But they are not as hard as diamonds and can be scratched by diamonds. Cubic zirconia are usually colorless, which isn't the case for diamonds. Most diamonds contain some amount of non-carbon impurity that makes them appear colored. And only very pure diamonds appear colorless.
What is heat capacity?
The amount of heat required to raise the temperature of an object by 1 degree Celsius.
How does pressure affect the rate of a chemical reaction in the gas phase?
In a gas phase chemical reaction, the pressure, or partial pressure, of a chemical species is directly related to its concentration. In just the same way we could write rate equations for solution phase reactions involving a constant multiplied by the concentrations of species, we can write rate equations for gas phase. Reactions that involve a constant multiplied by the partial pressures of species in the gas phase. So just like in a solution phase reaction, increasing the pressure of a reactant in the gas phase will increase the rate at which products are formed.
Why did Ilya Prigogine, Belgium, win the Nobel Prize for Chemistry?
For his contributions to non-equilibrium thermodynamics, particularly the theory of dissipative structures. Non-equilibrium thermodynamics is traditionally considered a particularly hard topic to address, because the assumptions one can usually make regarding the behavior of molecules are thrown out the window. Prigogine's work expanded on existing thermodynamic theories to address systems far from equilibrium, such as when a liquid is heated rapidly from below. Prigogine demonstrate that structures called dissipative structures could exist under conditions far from equilibrium, and that these structures could only exist in conjunction with the surrounding environment. Why did Peter D.
Why did Frederick Sanger, United Kingdom, win the Nobel Prize for Chemistry?
For his work on the structure of proteins, especially that of insulin. Sanger established the structure of insulin by first recognizing that it was made up of 2 chains of amino acids, one 31 and the other 20 residues long. He proceeded to establish the sequence of amino acids. All 51, in the 2 chains, thus determining the chemical composition of insulin. Insulin is a key peptide hormone that regulates glucose levels in the human body. In addition to characterizing the structure of this important hormone, Sanger in fact did much more. The methodology he applied to characterizing its structure went on to be used by numerous other scientists in many other situations to characterize protein structures.
What is a Pyrex, R, baking dish made of?
Pyrex, R, is a type of glass that was originally introduced in the year 1915 to be used in laboratory glassware and home kitchenware as well. It is a borosilicate glass composed of approximately 51% oxygen, 38% silicon, 14% boron, 1% aluminum, 1% potassium, and 0.3% sodium, by mass. Since its original introduction in the early 1900s, a different company has now become responsible for making Pyrex, R, glassware, and they now make it from a soda-lime glass, which is different from the original formula. This new formula is cheaper to produce than the original and is more resistant to breaking when dropped, but has poorer heat resistance.
What gives some people such a high alcohol tolerance?
From the biochemical point of view, the amount of the enzyme alcohol dehydrogenase in a person's body determines how rapidly their body can process alcohol. People with more alcohol dehydrogenase can convert ethanol, which is what gets you drunk, to acetaldehyde faster. A person's body size also is important, though. Bigger people have more mass to spread the alcohol around, so their blood concentration of ethanol doesn't rise as fast as that of smaller people.
What is a quantum number?
Values of conserved quantities in a quantum mechanical system. Electrons are described using 4 quantum numbers, n, the principal quantum number, L, the azimuthal quantum number, ml, the magnetic quantum number, and ms, the spin quantum number.
Why did Sir William Ramsay, United Kingdom, win the Nobel Prize for Chemistry?
For the discovery of the inert gaseous elements in air, and his determination of their place in the periodic system. Lord Rayleigh noted in a lecture that he measured a difference in the density of nitrogen made synthetically in the lab, and the same substance isolated from air. Ramsay followed up on this observation, quickly isolating argon for the first time. He went on to discover neon, krypton, and xenon.
What is an analyte?
An analyte is simply the chemical species whose properties we are trying to measure in an analytical chemistry experiment. Most often, analytical chemists are interested in measuring the concentration of an analyte present in a sample. The measurement of an analyte concentration is a quantitative observation.
What is electronic structure theory?
Electronic structure theory is an area of theoretical chemistry that is focused on calculating the arrangement and energies associated with configurations of electrons in molecules. This can include predicting the structure of a molecule, the most probable arrangement of its electrons, its reactivity, and different excited states of the molecule. For reasons we won't go into, this is not an easy task. And the electronic structure of molecules cannot be solved exactly, even with very powerful computers. Most theoretical chemists working in this area develop approximations for calculating the true electronic structure of molecules and on testing these approximations against available experimental data to continue to improve existing methods. The electronic properties of molecules play a vital role in determining their stability and reactivity. So despite being challenging, it's a problem well worth trying to solve.
Why did John Workup Cornforth, Australia, United Kingdom, win the Nobel Prize for Chemistry?
For his work on the stereochemistry of enzyme-catalyzed reactions, and Vladimir Prelog, Yugoslavia/Switzerland. For his research into the stereochemistry of organic molecules and reactions. Cornforth explored the stereochemistry of enzyme-catalyzed reactions by using isotopically labeled hydrogen atoms to study the geometry of their arrangement in the enzyme's active site. Prelog studied how the stereochemistry of organic molecules affected their reactivity, leading to important discoveries. He also explored the stereochemistry of enzyme-catalyzed reactions, observing how they reacted with simple organic molecules. Why did William N.
What is heat?
Heat is responsible for all types of energy transfer, other than those that fall under the definition of work. One easy example to think about is ice cream melting on a hot day. Because the ice cream is at a lower temperature than its surroundings, heat flows from the surroundings to the ice cream, causing its temperature to increase, and eventually it melts. There are lots of other examples of heat flow too. It's a pretty big category since it covers all types of energy transfer that aren't defined as work.
How do the atomic radii of atoms change across the table?
The atomic radii of atoms generally decrease going from left to right across a period, and increase going top to bottom down a group. See graphic on next page. The increase in atomic radius going down a group is fairly straightforward to understand. Additional shells of electrons are added and they must surround the inner shells, resulting in an increased atomic radius. Though the number of protons in the nucleus increases going down a group, the inner shells of electrons serve to shield the valence shell from the attractive force of the nucleus, resulting in an overall increase in atomic radius. Moving to the right across a period, the number of protons increases, increasing the attractive force on electrons in the valence shell. Within a period, additional electrons go into the same valence shell, and an increasing attractive pull from the nucleus results in a more contracted valence shell, resulting in a smaller atomic radius. The situation is complicated by the rightmost group, known as the noble gases. But the atomic radius of these elements is typically not important as they are rarely involved in chemical bonds to other atoms.
What are comets made of?
Comets are space snowballs with some dirt sprinkled in. No, really. Comets are typically balls of rock, frozen water, and gases. Sometimes other chemicals are present in much smaller amounts. These include methanol and ethanol, hydrocarbons, and in 2009 NASA's Stardust mission confirmed that glycine, an amino acid, was present in the comet called Wild 2.
Is NMR the same as MRI?
MRI, or magnetic resonance imaging, is based on the same principles as NMR spectroscopy. While NMR is typically used to investigate problems related to chemistry and physics, the goal of MRI is to image nuclei in living things. This is accomplished in a way similar to how an NMR spectrum is collected, except that the applied magnetic field has a gradient, meaning the field strength is different in different parts of the sample being imaged, usually human or animal tissue. This allows the use of microwave radiation to excite nuclei in individual slices of tissue, one at a time. The gradient in the magnetic field can be varied to collect the MRI of different slices of tissue, which can then be analyzed to get a picture of what is going on inside the body.
What is crystallization?
Formation of crystals from a solution of the compound, often used as a purification technique.
Is it good to drink chocolate milk after a workout?
Yes. Milk contains a significant amount of protein, roughly 8 to 11 grams per cup. It is often recommended to consume 15 to 25 grams of protein after a workout session. So drinking 2 to 3 cups of chocolate milk would meet this suggested quantity. In comparison to regular milk, chocolate milk has about twice as many carbohydrates, which is good for soothing sore and tired muscles. Of course, it also serves to rehydrate your body from the water lost during the workout. Moreover, milk provides you with nutrients like vitamin D and calcium.
What is an enzyme?
An enzyme is a protein whose function is to serve as a catalyst for a chemical reaction within a biological system. Some functions that enzymes perform are the synthesis of proteins and other biomolecules, digestion of fats and other molecules, and sometimes they are even put to use in industrial applications outside of their natural biological environment.
How do you measure molecular weight of a polymer?
The most common way is based on size. The technique is known as size exclusion chromatography, or gel permeation chromatography. The sample is passed through a column that has a porous solid material. The smaller polymers can work their way into those pores, while larger molecules don't interact with the solid material. The biggest molecules, because they don't interact with the solid phase, come out of the column first, followed by smaller and smaller molecules. The time it takes for a polymer to get through the porous column is related to its molecular weight. Okay, technically it's based on the hydrodynamic volume, but let's let this approximation slide. In practice, these instruments are calibrated using standard polymer samples of a known molecular weight.
What is the half-life of a radioactive species?
The half-life of a radioactive species is the amount of time it takes the quantity of the species to decrease by half. After one half-life, one half of the initial quantity of material will remain. After 2, 1/4 will remain, after 3, 1/8 will remain, and so on. Half-lives of radioactive nuclei vary widely, and we'll list just a few values below to give an idea of the range of timescales covered.
What is interference?
superposition of two or more waves, resulting in either higher constructive, or lower destructive amplitude.
Can anything travel faster than the speed of light in a vacuum?
No, or at least it's presently thought that this would be impossible. It's interesting, though, that there have been a couple of experiments in recent years which have observed particles called neutrinos moving faster than the speed of light. Even the scientists who carried out these experiments questioned the results. However, and they encouraged others to try to confirm their results, or to find where a mistake might have been made in their measurements. In the end, they did find out that these results were caused by a mistake. There was a loose electrical cable that caused enough error to invalidate the results.
What is a beta particle?
Beta particles are another type of particle that can be emitted during a nuclear decay process. A beta particle can be either an electron or a positron, which is the antiparticle of an electron. If it is an electron being emitted, one of the neutrons in the nucleus must become a proton to conserve charge in the process. Beta decay increases the number of protons in the nucleus by 1 and leaves the atomic mass essentially unchanged.
How are transition metals important in photosynthesis?
Chlorophyll, the green pigment that plays a crucial role in photosynthesis, contains an atom of magnesium at the center of its porphyrin ring. A porphyrin ring is an organic ring molecule found in many biochemical systems. The Mg atom plays a crucial role in the absorption of light from the sun, the energy from which is then channeled through the molecule and is eventually put to work by the plant's cells.
Why did Jaroslav Hayrovsky, Czechoslovakia, win the Nobel Prize for Chemistry?
For his discovery and development of the polarographic methods of analysis. Hayrovsky was an innovator in the field of chemical analysis, developing a polarographic method of analysis capable of analyzing the presence of virtually any species dissolved in water, and could determine the relative percentages of the species present. He did this using a method that we won't get into here, but it relied on a fairly simple procedure involving the application of a current and measuring drops of mercury.
How does fertilizer work?
Fertilizers are used to get elements that plants need into the soil. when the natural environment doesn't provide sufficient quantities. The typical elements are nitrogen, N, phosphorus, P, potassium, K, calcium, Ca, magnesium, Mg, and sulfur, S. They're actually labeled by the elements they contain. Next time you're at a garden store, look for NPK or NPKS on a bag of fertilizer. The numbers after these codes tell you the weight % of these elements in the bag.
How many phases can be in coexistence?
A rule called the Gibbs phase rule tells us how many phases can be in coexistence for a given substance or mixture. The rule arises from the fact that, to be in coexistence, a constraint exists that the chemical potentials of each component in each phase must be equal. After some math, one can find a relationship between the number of components of a system, the number of free variables, such as temperature, pressure, or the fraction of a given component present in a mixture, and the number of phases that can be in coexistence. This relationship is, F equals Cp plus 2, where F is the number of degrees of freedom. C is the number of independent components, and P is the number of phases.
Why did Henry Taube, United States, win the Nobel Prize for Chemistry?
For his work on the mechanisms of electron transfer reactions, especially in metal complexes. Taube investigated a series of ions of cobalt and chromium, finding that certain species reached chemical equilibria in solution, while others did not. A careful series of experiments demonstrated that, in some cases, a bridge was required to form between a pair of metal ions, or one of their ligands, before electron transfer could take place. In other cases, electron transfer could take place at a distance. These observations turned out to have important applications for many chemical processes, particularly in the field of biochemistry. It is also noteworthy that, at the time he won the prize, Taube had already established a strong history of being the first in the entire field of chemistry to report significant discoveries that were of great importance to the field. His importance to the field of coordination chemistry was recognized by the Nobel Committee. And the following quote is from one of their reports: "There is no doubt that Henry Taube is one of the most creative research workers of our age in the field of coordination chemistry throughout its extent. He has for 30 years been at the leading edge of research in several fields and has had a decisive influence on developments."
How could algae potentially be used as a source of energy?
Algae are potentially a very useful source for biofuels. but currently the cost of using them as a source of biofuels is too high to make them practically useful. One current area of research involves using the algae biofuel production process to produce a byproduct that is rich in protein and that could be used to feed farm animals. This would help to offset the cost associated with algae biofuel production. Since corn is currently used to both feed animals and to produce ethanol for fuel, the protein-rich byproduct could also help by reducing the amount of corn that needs to be grown. Cars can run on an ethanol-gasoline mixture with 10% ethanol, E10, but to use an 85% ethanol mixture, E85, requires a specially designed system. Ethanol burns much cleaner than gasoline, making it less hazardous to the environment. It is also a renewable resource that can be produced by growing crops. So it has the potential to reduce dependence on foreign oil sources.
How are transition metals important for nitrogen fixation?
Nitrogen fixation is the term for a process that converts diatomic nitrogen gas, N2, in the atmosphere into ammonia, NH3. This is a very important biological process because it converts N2, which is very unreactive, into a form that can more readily be incorporated into amino acids and other molecules. Transition metals, such as vanadium or molybdenum, are found in the active sites of the enzymes that carry out this important reaction.
Can eating carrots help your eyesight?
It does seem likely that carrots help your eyesight, so it's not a myth. Carrots, and other colorful vegetables, tend to have a lot of vitamin A. And vitamin A helps the retina to stay healthy and working well. This is because it helps to generate rhodopsin, which is a light-sensing molecule located in the retina. Developing a deficiency of vitamin A can actually lead to night blindness.
How is liquid extraction used in the chemistry lab?
Liquid extraction is a technique that exploits the differential solubilities of compounds between two liquid phases to extract the compound we want into a single phase. The liquids being used must be immiscible, meaning that they form two separate layers when placed in the same container. The goal is to have our compound of interest dissolved exclusively in a single liquid phase and also to have it be the only chemical compound dissolved in that phase. If this can be achieved, the liquid layer containing the desired compound is then separated and the solvent is removed, yielding the pure substance.
What is potential energy?
the energy contained within an object as a result of its current state, its charge distribution, its position relative to other objects, etc.
What is viscosity?
A property describing the consistency of a fluid by its ability to be deformed by stress. This is related to its ability to flow.
What is a thorium reactor?
A thorium fuel cycle is also possible for use in nuclear power reactors. This involves using thorium-232 to generate uranium-233, which is capable of undergoing fission processes to generate energy in the form of heat.
Why did Venkatraman Ramakrishnan, United States, Thomas A. Stites, United States, and Ada Ionath, Israel, win the Nobel Prize for Chemistry?
For studies of the structure and function of the ribosome. Ramakrishnan, Stites, and Ionath are responsible for uncovering the structure and function of the ribosome at the atomic level, and it is for that work that they share this Nobel Prize. They used X-ray crystallography to individually map each atom that makes up the ribosome. It consists of hundreds of thousands of atoms. The ribosome plays a crucial role in each cell, as it is responsible for the synthesis of proteins. On the basis of their results, these researchers have also developed models showing how antibiotics bind to the ribosome.
What is vulcanization?
Natural rubber that comes directly from rubber trees looks nothing like your car or bike tires. It's sticky, doesn't hold its shape when it gets warm, and if you live where it snows, it can get brittle. That sounds like an awful material to make a tire out of. Vulcanization creates cross-links in the rubber with the addition of sulfur to the natural rubber chains and improves all of these properties.
What chemicals are produced on the largest scale?
In terms of volume, not profit, sulfuric acid is the largest chemical produced worldwide. Global consumption is around 200 million tons per year, a number that is just too impossibly large to imagine. Nitrogen, N2, ethylene, CH2CH2, oxygen, O2, lime, mainly CaO, and ammonia, NH3, round out the top 5, though sometimes these change.
What is a ligand?
a group, an ion or a molecule, that coordinates to a metal atom, forming a coordination complex.
What wavelengths of light from the Sun reach Earth's surface?
The light from the Sun reaching the Earth's surface spans a range of wavelengths between roughly 300 to 500 nanometers, with a few gaps in between where atmospheric water and carbon dioxide absorb radiation. The range of wavelengths spanned by light in the Earth's upper atmosphere is slightly broader, demonstrating that gases present in the atmosphere absorb a notable amount of light before they reach the Earth's surface.
Is our Sun unique?
Aside from the fact that we're spinning around it, not really. It's a yellow dwarf star of average size, 6.960 x 108 m radius, 1.989 x 1030 kilograms, and surface temperature, 5500 to 6000 K.
What is the electromagnetic spectrum?
The electromagnetic spectrum describes the entire range of frequencies, or wavelengths, possible for electromagnetic radiation to have. In principle, the spectrum is practically infinite, though there are limitations on how high or low of frequencies we can practically achieve and work with. On the high end of the frequency spectrum are usually gamma rays, with frequencies of around 1020 Hz. While on the low end are extremely low frequencies of only a few Hz.
What is alpha radiation?
Alpha radiation involves the fragmentation of the nucleus into two particles, one consisting of two protons and two neutrons, an alpha particle, or in other words, a helium nucleus, and the other consisting of the remaining protons, neutrons, and electrons initially present in the parent nucleus. Alpha decay decreases the number of protons in the nucleus by 2 and decreases the atomic mass of the nucleus by 4 amu.
How does popcorn pop?
The shell of a popcorn kernel is a hard, moisture-resistant coating protecting an interior filled with starch and some water. As the kernel gets hot, the starch inside first softens and then the water turns into steam, which raises the pressure inside the kernel. At some temperature the pressure inside the corn kernel is high enough to rupture the hard shell, and the kernel pops. The hot starch quickly cools, trapping tiny air bubbles inside and making a delicious, solid foam.
What do the chemical structures of vitamin molecules look like?
Above are the structures of some common vitamin molecules. They typically have a molecular weight in the neighborhood of 100-1500 g/mol.
What is a polydentate?
A ligand is described as polydentate if it can bind to a central atom multiple times.
What makes metals good conductors?
An electrical current is the movement of electrons. So a conductive material allows the free movement of electrons. Metals are good conductors of electricity because of their electronic structure. There are basically two big groups of orbitals in metals: the valence band and the conduction band. The valence band is the group of orbitals that are normally filled in a metal, while the conduction band is empty. These are called bands because they are made up of sets of closely spaced energy levels. Metals, and other good conductors of electricity, can have very small or no band gaps at all. Semiconductors have small band gaps. And electrons can be promoted from the valence band to the conduction band either by heat or light. Insulators, materials that do not conduct electricity, have large band gaps.
What is hyperconjugation?
Hyperconjugation is another way to explain why substituted carbocations are more stable. The electrons in either the CC or CH bonds that are near the cationic center can interact with the empty p orbital. It's not the bonds that are directly connected, but rather one bond removed from the center carbon, that are the most important. See the illustration below. At the simplest level, this provides an explanation for the statement in the previous answer that neighboring carbon atoms are more electron donating than hydrogen atoms. It's really the neighboring CH bonds that help stabilize the empty p orbital.
Why did Adolf Friedrich Johann Butenandt, Germany, win the Nobel Prize for Chemistry?
For his work on sex hormones, and Leopold Ruzicka. Croatia, for his work on polymethylenes and higher terp NS. Butenandt was the first to isolate and crystallize a compound with the characteristics of a male sex hormone by extraction from male urine. Butenandt characterized the chemical formula of this complex, and called it androsterone. It was then discovered that this compound was actually slightly different from testosterone. But Butenandt and Ruzicka were both able to synthesize testosterone from androsterone. Ruzicka synthesized the same compound, androsterone, that Butenant isolated from male urine. He too was able to convert it into the male sex hormone testosterone. Ruzicka also worked to synthesize and characterize polyterpene complexes that are related to physically and biologically important compounds, including sex hormones. Ruzicka's work contributed greatly to the knowledge surrounding sex hormones, which, of course, are very important physiologically. And his work thus laid the ground for future investigations into the roles of these complexes.
What was the first molecule detected in space?
Hydrogen was probably the first molecule ever detected in outer space. But you're probably thinking of something larger than that. If you exclude diatomic molecules, like H2, N2, O2, etc. Formaldehyde, H2CO, was the first molecule detected in space.
Can chemical reactions involve multiple steps?
Yes, and many do. While some chemical reactions may only involve a single step, others may involve 10 or more elementary steps. Of course, chemists working in different subfields may have different definitions of what constitutes a step of a reaction, depending on what aspects of the reaction they focus on.
What makes something magnetic?
As we mentioned just briefly above, electrons have a property called a spin, or spin angular momentum, which can take on two possible values. This property, combined with the fact that electrons are charged particles, dictates that each electron has an associated magnetic moment, called the spin magnetic moment. In a macroscopic object, magnetism, or lack thereof, is determined by whether these spin magnetic moments are all aligned in the same direction. If all of the spin magnetic moments line up in the same orientation, the object will behave as a magnet. If the spin magnetic moments are oriented randomly, the object won't be magnetic. The trick is that only certain materials have the potential to exhibit magnetism. And we'll get to that next.
Why did Hermann Emil Fischer, Germany, win the Nobel Prize for Chemistry?
For his work on sugar and purine synthesase. Fischer showed that various molecules from plants and animals, which were initially not believed to be related, were in fact structurally similar. He went on to show that various sugars could be made in the lab from simple chemicals like urea, with the ability to make sugar molecules. he proceeded to establish the three-dimensional structure of every known sugar.
What's the difference between baking soda and baking powder?
Baking powder is a mixture of three things: baking soda, an acid, and a filler, usually cornstarch. The acid takes the place of the buttermilk or lemon juice in a recipe, see the previous question. To release CO2 from NaHCO3. The starch is in the mix to keep the two components from reacting before it gets into your cookies and to keep everything dry.
What is energy?
In chemistry, energy serves as the currency for making or breaking chemical bonds and moving molecules, or matter, from one place to another.
What is work?
Work is a name used in physics for processes that transfer energy between objects by the application of a force over a distance. Take throwing a baseball, for example. As your arm moves, your hand applies a force in the direction the baseball is moving. During the time the ball is in your hand and moving forward, you are doing work on the ball. The total amount of work done can be calculated as the product of the force you apply times the distance over which you applied force. Once it leaves your hand, you're no longer applying a force, so you aren't doing work on it anymore.
What is a neutron?
Neutrons are the other principal component of the nucleus of an atom, along with protons. The neutron is neutral in charge and has a mass roughly similar to that of a proton. Atoms of the same element that contain different numbers of neutrons will generally still have the same behavior as one another in terms of chemical reactivity properties. Both protons and neutrons are, in fact, made up of even smaller particles. But chemistry doesn't usually deal with these even smaller bits.
When was NMR invented?
The first time NMR spectra were recorded was in 1945, and two different research groups accomplished this independently, one at Stanford and the other at Harvard. These groups were led by Felix Bloch, Stanford, and Edward Purcell, Harvard, who shared the 1952 Nobel Prize in Physics in recognition of their great discovery. See the list of Nobel Prize winners in chemistry in the back of this book. Pound. The location of the peaks along the x-axis is known as the chemical shift, and this value can be related to the electron density surrounding each nucleus. In some NMR spectra, the intensities of each peak, their height on the y-axis, can be related to the number of nuclei of a given element that are present. There are more and more details that one learns after spending lots of time interpreting NMR spectra. But these are the basic principles that allow a chemist to relate an NMR spectrum to a chemical structure.
What is a chalcogen?
A chalcogen is an element in group 16 on the periodic table. This includes oxygen, sulfur, selenium, tellurium, polonium, and livermorium. This name comes from the Greek word meaning copper former, and has its origins in the fact that some of these elements tend to coordinate to metals to form compounds with metals in ores.
What is an ideal gas?
An ideal gas is a collection of atoms or molecules that do not interact with one another and occupy essentially no volume. While this is an idealized model, it turns out to describe many gases very well. The reason it works so well is that the atoms or molecules making up a gas are spread out far from one another so that the intermolecular forces between them are extremely weak, they don't feel each other. This description leads to the ideal gas law, which is a relationship between the pressure, volume, and temperature of a gas. The ideal gas law allows chemists to predict how, for example, the volume of a gas will change as its temperature is increased. The equation for the ideal gas law is PV equals NkBT, where P is pressure, V is volume, N is the number of particles, atoms or molecules, T is temperature, and Kb is Boltzmann's constant, a fundamental physical constant.
What is a catalyst for a reaction?
A catalyst for a chemical reaction is any chemical species that lowers the amount of free energy necessary to achieve the chemical transformation. This may involve a significant change in the mechanism by which the reaction takes place. Light may also serve as the catalyst.
Why did Fritz Pregel, Austria, win the Nobel Prize for Chemistry?
For his invention of the method of microanalysis of organic substances. Pregel, a chemist and physician, was awarded the prize for his work on ways to quantitatively characterize organic molecules. In particular, he made great improvements to elemental analysis, which reveals the amount of various elements in a substance by measuring the combustion products. Or, more simply, burn the stuff and see how much CO2, H2O, and NO are released.
What is a fatty acid, and what is the difference between saturated and unsaturated fats?
Fatty acids are long, organic molecules that contain a carboxylic acid functional group at one end. See the picture below, and a long, nonpolar tail at the other end. They are an important source of energy in the body because they can be metabolized to generate ATP, which the body uses as fuel. When you're looking at the nutrition information on your food, the concept of saturated versus unsaturated fats can be understood by looking at the structure of a fatty acid. Saturated fats are those that contain only single bonds connecting each carbon atom in the chain. Recall that double and triple bonds are called units of unsaturation. Unsaturated fats are any fats that do have units of unsaturation, or, in other words, that do have double bonds between some of the carbons in the chain. All fats are either saturated, top illustration, or unsaturated, bottom illustration.
What is a dependent variable?
A variable that changes as a function of the independent variable.
If chlorophyll gives plants its green color, then what cells give me my skin color?
Melanin is the molecule that is responsible for skin color in humans. It's also what gives your eyes and hair their color. There isn't one single structure of melanin. Rather, it refers to a whole class of highly colored molecules that are all derived from the amino acid tyrosine.
What is a plasma?
A phase of matter in which a significant fraction of electrons have been ionized from their nuclei.
Why did Robert Burns Woodward, United States, win the Nobel Prize for Chemistry?
For his outstanding achievements in the art of organic synthesis. Woodward made tremendous research achievements in a broad range of areas in the field of organic synthesis. He established the structures of aureomycin and terramycin, which are antibiotics, and made possible new synthetic work in this area. He also synthesized quinine, which was considered a great challenge and was used to fight malaria. And later synthesized cholesterol and cortisone. The list of synthetic achievements goes on and on. And he truly ranks among the most successful synthetic chemists ever to have graced the field. In addition to these synthetic achievements, Woodward also established the structures of a large number of important compounds.
Why does the sun glow?
The fusion processes happening near the core of the Sun cause energy to be given off in the form of photons. See Physical and Theoretical Chemistry. The photons given off in the core of the Sun collide with other atoms, which absorb photons and, in turn, give off additional photons. This process repeats, potentially millions of times, before photons at the surface of the Sun are emitted off into space. As a side note, everything tends to emit radiation in this way. At least to an extent. It's just that most things on Earth are not nearly as hot as the Sun. Even your own body releases electromagnetic radiation. But the photons coming from your body are in the infrared region of the spectrum, so we cannot see them with our eyes. However, infrared cameras can use the photons given off by a person's body to locate people or animals, in this way.
How large are molecules?
Molecules span a wide range of sizes. The smallest molecules contain only 2 atoms. And these diatomic molecules have length scales that are approximately the sum of the atomic radii of the constituent atoms. The smallest molecule, HH, has a length of only 0.74 angstroms, 7.4 x 10 to 11 m. Larger molecules can be comparatively quite large. Biologically important molecules, like proteins, often contain thousands of atoms. Polymers, which are highly linked networks of covalently bonded atoms, can be even larger still, sometimes becoming so large they are visible to the naked eye.
What's the difference between alchemy and chemistry?
Let's ask Robert Boyle, who in 1661 published The Sceptical Chymist, arguing that experiments disproved the idea that the universe was composed solely of Aristotle's 4 elements. Boyle himself was an alchemist, in that he believed that one metal could be changed into another. But he was a staunch promoter of the scientific method and helped elevate chemistry to a science. So one could simply say that alchemy is a philosophy, while chemistry is a science.
What is the second law of thermodynamics?
There are several different statements of the second law of thermodynamics, but they are all centered on the idea of identifying what things can happen spontaneously in nature. One formulation of the second law states that, for a closed system, the entropy of the system can only increase or remain the same. In plain language, this says that nature favors having more accessible configurations or arrangements. It's why, for example, a drop of ink in water tends to spread out to fill its accessible volume but won't spontaneously reform a drop of ink. Another statement of the second law says that heat cannot Spontaneously flow from a colder body to a warmer body. Work would have to be done for this to happen, which would imply the process was not spontaneous.
What is cooperativity?
Cooperativity describes how the binding affinity at one site of a protein affects the binding affinity at another site. In hemoglobin, for example, there are 4 sites at which oxygen molecules can bind. After the first oxygen molecule binds, conformational changes take place in the rest of the protein that increase the binding affinity at the other sites. The second oxygen is then able to bind even more easily, and the third and fourth even more easily yet. This gives rise to a sigmoidal curved shape in a plot of the fraction of hemoglobin bound by O2 versus the partial pressure of O2, see illustration. Similar binding curves result in other examples of cooperativity. Though the example of hemoglobin is probably the most commonly discussed example of the phenomenon.
Has a Nobel Prize ever been awarded for a discovery in the field of green chemistry?
Yes. Although green chemistry is a relatively young field, one Nobel Prize has already been awarded for work in this area. This prize was awarded in 2005 to 3 men, Robert Grubbs of the California Institute of Technology, Richard Schrock of the Massachusetts Institute of Technology, and Yves Chauvin of the Institut Français du Pétrole, for their work in the development of olefin metathesis reactions. Olefin metathesis is a type of chemical reaction that involves 2 carbon-carbon double bonds reacting to form 2 new carbon-carbon double bonds, effectively exchanging the substituents attached to each carbon. This reaction takes place catalytically under mild reaction conditions, produces little hazardous waste, and has been shown to be effective in a broad range of situations, including the synthesis of new drugs.
When did the theory of the atom come about?
The idea of the atom was originally proposed by ancient scholars. The philosophers Democritus and Leucippus are often credited with proposing the early notions of the atom, including the ideas that many different kinds of atoms exist, that there is a substantial amount of empty space between atoms, and that their properties are responsible for the properties of materials we see and interact with. For centuries, ideas about the structure and properties of the atom were based largely on conjecture and logical arguments. And it wasn't until the 1800s that experiments began to allow atomic theory to advance to where it is today.
Why did John B. Fenn, United States, and Koichi Tanaka, Japan, win the Nobel Prize for Chemistry?
for the development of methods for identification and structure analyses of biological macromolecules. For their development of soft desorption ionization methods for mass spectrometric analyses of biological macromolecules and Kurt Wuthrich. Switzerland, for the development of methods for identification and structure analyses of biological macromolecules for his development of nuclear magnetic resonance. Spectroscopy for determining the three-dimensional structure of biological macromolecules in solution. In the past, mass spectrometry was limited to the study of relatively small or lightweight molecules. Fenn and Tanaka share half of this prize for their work in extending the technique of mass spectrometry to significantly larger biomolecules. Fenn and Takana independently developed two different methods for obtaining freely hovering protein samples appropriate for mass spectrometric analysis. Wuthrich received the other half of this prize for the use of NMR spectroscopy to determine the three-dimensional structure of biomolecules in solution. This represents a significant advance beyond crystal structure analyses, as the structure of biomolecules may differ in the crystalline and solution phases, with the solution phase structure being more relevant to their true biological function.